Here we have some very important Maclaurin series which we consider as formulas. So we know that cosine x is equal to, let's write, cosine x is equal to sigma n from 0 to infinity negative 1 power n times x to the power 2n by 2n factorial. So notice cosine has alternative negative positive, but x's powers are even here, right? This is true for all x. That means radius of convergence for this series is equal to infinity. So now in our question, we need to not write about cosine x. In place of x, cosine of x squared by 2. So that means for using this formula, we are going to use in place of x, wherever there is x, we are going to replace what? X squared by 2. Let's do that. So I can say if cosine x is equal to the series, then cosine x squared by 2 will be, you see everywhere I'm copying the same thing, but in place of x, I'm writing x squared by 2 power 2n. Okay, let's write it one more time. Negative 1 power n. This 2n power goes inside, becomes x to the power 4n. Divided by 2n power goes for 2 also, which is 2 to the power 2n goes in the denominator times 2n factorial. Okay, but we don't only want cosine x squared by 2, we also want to multiply it by x. So if I have to multiply, I want to get x cosine x squared by 2. I'm going to do what? I'm going to multiply by x on both sides. Okay. So now I need to take this x multiply inside. What will that be? Sigma n from 0 to infinity negative 1 power n. This x when multiplies with this is x to the power 4n. This can be written as this here is being multiplied with this x. Bases are same, the powers will add. X to the power 4n plus 1 divided by 2 to the power 2n times 2n factorial. So this is our answer. The series, you see, you don't always have to write. If you remember the standard Maclaurin series, you can use that to write some of the functions faster. We know that radius of convergence here would be infinity because this is true for all x. We have a similar example. Use the following tangent inverses Maclaurin series. Remember, Maclaurin series means that we are writing Taylor series with a equal to 0. The radius of convergence in the book is written here for this series as 1. Okay, so f of x is equal to this. This is arctangent, that can also be written as tangent inverse. It's just a different way of writing it, arctangent and tangent inverse. We have the series for tangent inverse x. In place of x, we need to replace x square. So that should be sigma n from 0 to infinity negative 1 power n by 2n plus 1. But wherever there is x, we are going to replace that by x square power 2n plus 1. And the radius of convergence of this should also be equal to 1. So sigma n from 0 to infinity, negative 1 the power n. Power of powers multiply. So this is going to become 2 times 2n plus 1 will be 4n plus 2 divided by 2n plus 1. So tangent inverse of x square can be written as this series. See, we didn't work through from scratch. We already had a basic series, remember, tangent inverse x. We use that to write tangent inverse of x square. Here is another example of Maclaurin series of, say, function is sine of pi x by 4. Here we are going to use standard Maclaurin series of sine x, which is convergent for all x. So radius of convergence is infinity for this. So we need to write sine of pi x plus pi x by 4. Basically, in place of x, wherever there is x, we need to replace it by pi x by 4. So that's going to be n from 0 to infinity, negative 1 power n. In place of x, what are we going to write? Pi x by 4 power power is same, 2n plus 1 divided by 2n plus 1 factorial. This is true for all x, meaning radius of convergence is up to infinity. Okay. Negative n from 0 to infinity, negative 1 power n. We are almost done. We just need to put powers everything. So pi power 2n plus 1 times x power 2n plus 1 divided by 4 power 2n plus 1 is gonna come here in the denominator times 2n plus 1 factorial. Okay, so for sine pi x by 4, the expansion, Maclaurin series expansion is this. We can put n equal to 0 and get one term, n is equal to 1 as second term, and so and so. And we will define that radius of convergence here is infinity. It is true for all x. So all these questions, 3 questions, see, we were using older Maclaurin series, which we already kind of know. These are called standard Maclaurin series because we use them as a formulas to write any of the sine or cosines or tangent inverses Maclaurin series. Remember, Maclaurin series just simply means that A is equal to 0 in the Taylor series.